Hi everyone, welcome back to my channel. So as I promised, I'm continuing now with the ML course with a simple numerical example of each algorithm. So I'm trying to simplify the concept and equations with a simple with numerical examples. So in today's video, I will try to dive into KNN, how it's working, or K nearest neighbor. So as you can see, all of this already covered, and plus the Python linear regression and others. So let me jump to the document. KNN. What is the KNN? So KNN is supervised learning that used to classify for the classification of or even for the regression. It's try to find. Let's say you have a point, you have a test example, and you would like to see what is the nearest class or what is the nearest point to this points to this let's say to this points. So I think this graph should be easy to follow. Let's see. So I have taken this from this website. So assume that you have this is what the blue and red circles are the training data set. And for the test data set, let's say you have this data set, table, let's say example, and you would like to see what is the closest or the nearest point to this point here. So as from this example, you can see this is the red point here. And if you have this, when we say the key is 1, the key, it means the closed number 1. And here you see you have key equal 3. And what is the closed 3? We can see this and this and this. But now we will see using the float which class label should be used. For instance, here you have red and 2 blue. Then the class label should be blue based on the majority. And if it's 4, you see 1 2 3 4, but now this won't let's see be defined. So the one recommendation to use KNN, try to use an odd number, 3 5 9 and etc. So, and by the way, this KNN is called lazy linear because it's not building a model during the training. It's just storing the data set, and for the prediction, you have to calculate the distance from this point from the new point to the whole data set. It's called lazy linear. So it's not like, let's say, a support vector machine or decision tree. In the training, we have a build a model, and for the testing, we just use this model. But here, it's not using the model, creating, let's say, a model. And how is this working? So let's see. It just you need to choose number of closed. So don't if you didn't understand this theory, I will try to explain it here with equations and examples. So don't worry. So how it works? So as I said, we have to select number of key values as we have done it here. So you have to select, let's see, the close 3, 5, and points, and we use three. It called the let's see the key is the three close point, and we need to select the matrices, the metrics. So usually we use Euclidean distance and maybe Manhattan distance or mini quiz key. Quiz key, Euclidean distance. I think it's a subset, or let's see, from the minus key, because it's used this square root, and minus key maybe it could be 3, 4, 5, 6. And let's see here we have an example here. The goal, as I said in the beginning, KNN is not building a model. It's just calculating the distance from the point against the whole data set. Let's say we have this data set here, and we would like to classify this new fruit. Let's say here we have fruit, and we have weight in grams and sweetness, and this is a class label. Sorry, I have flu. And we need, let's say, to classify the new fruit which has these parameters here, let's say these attributes, and which class label should be used. So would we like to classify it as apple or orange? We will see. So let's consider key is equal 3. This is the primary, let's see, primary parameter, let's say, for the KNN. So, and this is the Euclidean distance. I will see x1 minus x2 plus y1 minus y2. So what is x1 and y2 and so x1 and y1? So you can see 1 is relevant to the point that we would like to classify. For instance, in this one here, this is x and this is y. And x2 and x2 and y2 are the coordinate of the training data set. Let's say we have this and this, x, y, and if you have many parameters, it's x2, y2, y3, and etc. So let's say I have, as I said, this is my point. I would like to find the class label that is relevant to this point. So it means the weight of this fruit is 165 and the sweetness is 7. So I will calculate the distance from this point to against all the training data set, which is indeed it takes much time if you have a big data set. So I recommend you not to use KNN. So I will calculate the distance. As you can see here, this is my x1 minus x2 plus y1 minus y2, and the distance will be 15. And calculate the distance with the same way against the all members, or let's say all tables or all rows. And after calculating the distance from the whole the whole training data set, now you need to sort all of these distances. Let's say sorting all of these distances here, and select the three, or let's say the top closed 3 points, and so you have here 3 points. It's fruit 2, fruit 3, fruit 1. This is the closest point to this to the new point, to the prediction point. Let's see, fruit 2, fruit 3, fruit 1, I think. Yeah. Now, and once we have this, we need to make, let's say, perform major, let's say, majority voting. So majority voting, it's like take the maximum class that has the maximum number. Let's say here we have 3 apples. So the maximum class, the maximum number of class, let's say it's apple, it has 3, of course. And you can see here apple is 3 and orange is 0. So we will take the maximum one. So here we have 3. And if it's, let's see if you have here orange 1 and you have 2, of course you will be able, you will choose apple for this. So it's like selecting the majority. So one question here, how to choose the best key? So there's indeed a problem for choosing the optimal key. So if you select, let's say, key equal 1, it will be highly sensitive to the noise, and maybe leading to overfitting. And if you choose large, let's say large key, it's also lead to underfitting. So the best way to choose it is use cross validation to find the optimal key. And now I have already prepared the Python code for this. Let me jump to the Python. And this example, it reflects exactly the same as the example in the document. So in case you would like to, let's see, make a debugging or to find, to do it yourself. So here I have the buoyants. And in reality, you need to load all of this data from a file, let's see. But this is for a simplicity. And here you have the data buoyants, and you have the Euclidean distance. We said we need to number of neighbors. It's defined as 3. We need to calculate the distance. Here we have Euclidean distance, and now I will calculate the distance from this point. Where is the point? Query point. This one here, against all the features, all the datasets. And the step 3 or 4, I will try to sort the distance based on the maximum number of distance. And here I will select the top, let's see, three distance, which is, key, which is 3. So it's from 0 to 3. And here you select the majority. And this will print the class of the new data. And this also only for the simplicity and for you just to understand how the KNN is working. And by using the sklearn, this is easy implementation. You just have the X and the Y, the class, let's say the data and the class label. And you have the new data points. And you have, for instance, define the key nearest classifier, and the key in and NN is 3 dot fit, and you can just predict the new classifier, the new point. So if you run this, you should have the same class label. It should be the same class label. You can see here pure Python. So this is the pure Python. Its class label is Apple, and Skyline it's Apple as well. So this is I'm trying to make it. I try to make it. Let's see, very simple or simplified this with this examples. So indeed, this took a lot of time for me to prepare this. And if you like this, please subscribe and like the video if you like it. And if you have any question, of course, drop it down in the comment below. I will answer it. Thanks for watching, and see you next time.